Mathematics was never hard for me in school. It was a subject that went very easily. Math is really everywhere. Yeah.
Tästä alkaa videosarja Samun guruhaastattelut. Ensimmäisenä haastattelen Carola Schönliebiä legendaarisesta Cambridgen yliopistosta. Carola on matemaattisen kuvanpaikkauksen asiantuntija. Ehkä muistattekin mun aikaisemman ahven-video, missä poistettiin ahven kuvasta. Ja nyt olisi tämmöinen toisenlainen tehtävä, missä pitäisi tämmöiset narut saada pois näkyvistä. Jos käytetään samaa harmonista kuvanpaikkausta, niin tulee vähän tommoinen sumunen jälki. Carolan koodilla sen sijaan saadaan paljon hienompi. Ja tämä parempi tulos perustuu niin sanottuun kokonaisvaihtelutekniikkaan, jonka mestari Carola on. Mennäänpäs kysymään Carolalta itseltään.
Well, here I'm with Carola Schönlieb, who works as reader at University of Cambridge, and she's an expert on mathematics related to image processing.
Yes, hello Samun. You have an image, like a photograph, for instance, and there is something in this image that you want to remove and replace it by something that is suggested by the rest of the image, that somehow naturally, seamlessly goes into the rest of the image and gives you the impression as if nothing has happened. Based on this distribution of colors at the boundary, I want to create inside an average of the colors from the boundary.
Yes.
You're diffusing the colors from the boundary into this whole. When you want to remove an object and the background is just, I don't know, blue sky, or just something that has a very smooth transition between the different colors, then this works very well. The moment you have sharp edges in your image that are hitting the whole,
yes.
This will not work well because it will blur, it will diffuse these edges, and it will not be able to propagate them inside. So this way of total variation in painting is that it makes the diffusion non-linear, in the sense that you can think of it as a kind of combination between transport and diffusion. It will be pure diffusion if there are no interesting structures, if the color around the boundary is very smoothly changing, very slowly changing. But the moment this color is changing rapidly, it will replace, or it will complement this diffusion by also a transport mechanism.
Ah, yes.
And then in this way it is able to also propagate edges into the whole.
How do you find working here at the famous university?
Yeah, it's great to work here. It's really, there are so many possibilities, so many smart people around, very ambitious and very passionate colleagues that I have, not just in mathematics but also in other disciplines, which is something that is also very exciting for me, because working in imaging and developing mathematical methods for imaging, it's really nice if they're used for something that actually might make a difference, in cancer research or in forest conservation. I have some collaborations, and so this is really, really exciting, I think, and I think the university here gives you all these possibilities of doing this.
Carola, thank you so much.
Thank you, Samun.
Excellent.